So before we get into this deeper, it's important that we're all working from the same definition of AI because there are a lot out there. So what is AI? How many of you think that machine learning and AI are essentially the same thing? Hands? Anybody? How many people think AI includes some machine learning and also some rules-based coding? Yeah. And also maybe optimized search algorithms or sorting algorithms? Yeah, so AI really includes usually some kind of combination of some or all of those things. And really because machine learning is going to give you some results, but it doesn't necessarily do anything with those results. I like to think of AI as a system and not just an algorithm or an ensemble of algorithms, and I'll kind of get into this a little more later. And my favorite definition of AI was by Andrew Moore, who is the former dean of the School of Computer Science at Carnegie Mellon University. And he said that artificial intelligence is the science and engineering of making computers behave in ways that, until recently, we thought required human intelligence. So we're trying to get computers to do things the way that, things that we used to think required a human brain. Now, there are two important types of intelligence to distinguish for our purposes today. One, there's a narrow intelligence, which is kind of the current state of AI right now, and it's where models and systems can only handle the information that they were built to handle or the data that they were trained on. And they can't really generalize the information that they have to anything they've never seen before or unlearned situations. And then the other kind of intelligence is general intelligence, and that's more like human intelligence. So we can generalize information about cats and dogs to other animals, like maybe a goat. So right now, if I trained an AI system on photos of cats and dogs, kind of like Alyssa was talking about earlier, and then that same system sees a picture of a goat, it can only tell you the probability that that photo is a cat or that that photo is a dog. It can't tell you anything else. And computers are kind of dumb in this way. So can we teach computers to say, oh, I've never seen that before? Yeah, we can do that with thresholding. So you could say, all right, I think 70% this could be a dog, and maybe 50% this can be a cat. But we can build into our system a rule that says, if you're not at least 80% sure that it's either a cat or a dog, you could say, I've never seen this before. So how does that differ from how a human would handle the same problem? Well, a human could do the same thing. If you are shown a picture of an animal you've never seen before, you can say, I've never seen that animal before. But you know it's an animal and not a tree or a human. So we can still generalize some of the information that we have to things that we've never seen before. AI can't do this yet. So should we be afraid that AI will take over the world? Short answer, no. Like I said, we are lifetimes away, I think, from general AI that can really kind of generalize and learn a lot more and handle unseen things. And so right now, computers can only do what we train them to do. They can only get the information that we give them, either explicitly by dumping data into them or implicitly by equipping them with sensors to collect their own data. But the long answer is there's still some ethical concerns and things that can go really wrong with AI. For example, if we feed AI systems biased data, we'll get biased results. And this can have real-life consequences for people. So if you think about biases in mortgage lending systems or credit rating systems or employment applications, having biases in these kinds of systems can be really detrimental to people. All right. So why has healthcare been so slow to adopt AI? Well, for the same reasons a lot of industries have been hesitant to sometimes adopt AI. And we'll get into the kind of universal reasons why AI can go wrong and why people are hesitant to adopt it. But there are a few additional barriers in healthcare that we have to overcome. And one is heavy regulation of the field, especially with the regulation of the way that personal health information is handled. Makes it a little more difficult. I know in terms of using cloud platforms, a lot of places have been very hesitant to send personal health information through cloud platforms for a variety of reasons. A lot of them are really legitimate reasons. And those things are being fixed, right? Like Google has options that can handle HIPAA data, for example. And so we're kind of headed in the right direction of being able to use a lot more tools like that in the healthcare field. And the other issue in healthcare that's especially daunting and big barrier is the gravity of potential damage. So if these systems make bad decisions, you're dealing with people's welfare, their lives. People can die, people can be injured, people can be seriously hurt. And so in addition to all the normal barriers of AI, there's some pretty big additional barriers in the field of healthcare specifically. So let's talk about the issue of biased data and how this can kind of happen. And one really good example of a biased data problem is Amazon's HR department. And they reportedly used an AI-enabled recruiting software that would review and kind of makes recommendations on which resumes might be good candidates for different positions. Well, they found out that this software was far more favorable to men than to women because they trained it on 10 years prior to the adoption of the tool, and during those 10 years, the majority of candidates who were hired were men. And so the software, or the program, started to downgrade resumes that contained words that implied that the candidate was a woman. So even though they removed gender information from what was being fed in, if they saw women's colleges, for example, it might downgrade the resume. Now, Amazon has since abandoned this software, and the company said that they never used it to actually evaluate candidates. They only used it for recommendations. But this is still problematic, right? Because if you're getting a recommendation of resumes to review, even though you're not using the software to actually evaluate the client or the potential hire, you're still missing a lot of resumes of good candidates who have been unfairly biased and removed from the candidate pool. Okay, reinforcement learning. So those of you who are not familiar with reinforcement learning is a special kind of AI where you kind of set a computer loose to figure out the best paths toward things. So you do this using like randomized search or exploration into different possible actions. And then you set up this reward system. So if it makes a good choice, it's rewarded. And it wants to maximize the reward, right? And so these are really great systems. If you Google reinforcement learning, the majority of results are usually around teaching computers to play different kinds of games, and it's really fun, you know. So one of the most popular examples is teaching a computer to play Atari Pong. That's how a lot of people get started, learning how to do reinforcement learning. But reinforcement learning is becoming prevalent in many AI applications, and it has some really interesting real-world applications that I think could be very beneficial. So one of them would be exploration into using autonomous cars for traffic control flow. So let's say a third of our population gets into autonomous cars. We can program those cars to actually control the flow of traffic to alleviate traffic jams and things of that nature. And so those are some really interesting applications of reinforcement learning that are coming out. But how can it go wrong? So one of my favorite examples of reinforcement learning going wrong is a floor cleaning vacuum. So if you think about a Roomba, for example. If you set it loose and you decided, okay, I'm going to let this thing train in reinforcement learning, and let's say the reward system that I've set up is going to reward it by, so it gets a reward if it minimizes the amount of dirt that it sees. Right? So to us, we're thinking, okay, this is kind of like the peanut butter and jelly example that Alyssa brought up earlier. Right? To us, we're thinking, okay, so it's going to vacuum up the dirt, it will see less dirt, it gets a reward, it's going to be great. Well, one of these actually decided to see less dirt by turning off its camera. Right? so you have to be very careful, you know, how you set up your reward systems, and we'll talk about how you can fix that, you know, later on. The other thing specific to healthcare related to reinforcement learning is that if you think about randomized exploration in healthcare, that's a really dangerous kind of situation, right? So let's say you're trying to find the best prescription drugs for different kinds of ailments. You can't exactly tell a computer, okay, just try all these different medications on different patients and see which ones work the best, right? Because you know, obviously you're going to hurt some people. So it's really not a good application in reinforcement learning. You have to be really careful how you use those. Okay, computer vision. So autonomous cars have a lot of problems, right? Still, that's why they're not fully autonomous, unfortunately, because I'm a terrible driver and can't wait to get in one. But this is a really interesting kind of situation that arose when cars first started to identify traffic signs. And so you can see this stop sign has a couple of black and white stickers on it. And what that does is it will actually fool a computer vision algorithm into thinking that stop sign is a 65-mile-per-hour speed limit sign. And so you can imagine how big of a problem that would be for an autonomous car. It's going to, maybe speed up when it should be stopping, okay? And we can kind of talk a little bit about why it happens this way. Because for us, we see a stop sign, there's so much red on there, and you kind of think, how could just a few stickers fool a computer algorithm, or a computer vision algorithm? Well, this is kind of how a neural net architecture looks. And you can see the two layers in the middle. The first layer is what's called an input layer, so that's just all the data you're feeding in. And then you have your hidden layers and your output layer, which is making your prediction of what something is. Well, for these nodes in the hidden layer, the number of nodes that you have determines how many features you can identify. So you can see if you go back to the stop sign, whoops, wrong way. So if you go back to the stop sign, you can see that essentially you have about 4 features that have been identified that make a 65 mile per hour. So there's 4 stickers here, which means there are essentially 4 features that will distinguish a 65 mile per hour traffic sign from any other sign. And that's kind of what neural nets do. They find the important distinguishing characteristics. And so when you get into these neural net architectures, if you were to make these big enough so that you could really identify every pixel instead of just the important edges, that'd be great. That's kind of how our brains work. Our brains actually are estimated to contain about 100 billion neurons. So what we're looking at in even these really deep architectures, which this is a simple neural net, but even in the really deep architectures, we're not getting anywhere near that number, right? And so in order to even do something like that, we would have to have way more compute power and time than what we have, because the deeper these things get, the more time they take to train, the more compute intensive they are. And so it's really just not possible to get that level of detail. Okay, cybersecurity. I'm not a cybersecurity expert, but this is definitely a concern, especially when you're in healthcare. You have to think about all of the connections. If you're working in the cloud, maybe the cloud platform is secure, but your connection to the cloud may not be. If you're working on-prem, you just have to be very careful about any connections that you have to the outside world, but because for all kinds of cybersecurity issues, especially when you're dealing with PHI. So job security, this is a big one, right? And I deal with this a lot. Will my job be replaced by a computer? Well, we went through this once before in the Industrial Revolution, and for one example, tractors were invented, right? Well, we needed fewer farmers after tractors were invented because one farmer can handle a lot more land with the help of a tractor. And so job security is definitely a concern. Absolutely, computers will start doing more of what humans do. It's not really clear how quickly that will happen, but there are it definitely will cause some change, and we could talk about this a little later as well. Okay, so all of those are issues to AI, but does anybody know what the biggest barrier to AI is right now? Exactly. Yeah, exactly right. So this is kind of the state of data for a data scientist right now, right? Like, we're asked to build these big, beautiful, stone islands, and they give us data that's like that marble gravel up in the top right corner. And put together this big, beautiful island with gravel, right? And you're going, well, it's not going to look like that, right? It's just impossible. There's no way that you're going to get from marble gravel to that. And so what we're starting to do in my work and my job is we're going back to the systems that are collecting data, and we're trying to collect better data, right? Fix the systems, get rid of free-form text fields. And so what we're doing is we're trying to go back, for this example, it's like the picture on the sorry. the left over here, the marble quarry, we're getting big slabs instead of small gravel, so we can do better things with it. Okay, so why don't computers think like we do? Well, neural networks, like you saw before, those are kind of patterned after the way that the brain functions. So our brain has a bunch of synapses and neurons, and it essentially sends electrical signals from node to node. And sometimes those signals are stronger than other times. And that's kind of what neural networks do. So it's going to send a signal node to node, and some of those nodes will be turned on, and some of those nodes will be turned off, similar to the way that our synapses work in our brain. And they were actually, when they were started, there were two guys who thought up simple neural network architecture back in, I think, the 50s. It was a long time ago. And they were actually saying, I think if you had these complex logic gate systems where everything's binary, 1 or 0, you can actually come up with a really good result. And that's how neural networks started. So if computers are patterned after our brain functionality, why can't they think like we do? Well, like I said earlier, our brains have 100 billion nodes essentially in them, and we can't come anywhere near that. But also, there's more to it than that, and it's a data problem as well, because if you think about how we get data as humans, since the time we were born, 24 hours a day, every day that we're alive, we have information coming in. We have people around us who are teaching us things. We're seeing new things. We have information that are coming from all of our senses. Every nerve in our body is providing us with data. Our eyes, our ears, we have a sense of taste. We are just constantly collecting data. And computers don't have that ability. One, because they don't have all the sensors that we have in our human bodies. So they are really limited by what we can give them and by how they're able to collect it. And so I think it's really more an issue of computers not having the prolific amount of data that we get, even less so than it is just not having the same number of nodes that we have in our brain. So how do we deal with these issues, right? So I hope I haven't instilled with you all hopelessness in regard to the future of AI, because my talk is Artificial Intelligence, the Future of Healthcare, right? So there are ways to reduce the risks of these issues. So in terms of bias data, this is a difficult one. And it really starts with awareness, right? Being aware of your data, being aware of our biases as humans, being aware of what past biases might be in our data, and trying to figure out how we can remove information that can be used for biases. And that doesn't just stop with removing, like if you're trying to stop a gender bias in regard to like the Amazon HR example, even removing the gender doesn't necessarily remove the bias, because there are other things in the data that can imply the bias. One thing that can help, especially in that example, is balancing out your data set. If you know you have like 100 women and 1,000 men, you can augment your data on women, and you can undersample your data on men, and come to a more balanced data set, and that might help with some of the bias, in addition to removing data that's specifically going to trigger bias, like race, gender, age, etc. With reinforcement learning, you can create test or pseudo environments for randomly exploring pathways. And so if you have some simpler problems, you might be able to kind of give it a fake patient, right? And have it try different things with a fake patient. And if it starts to perform very well, then you can remove the random exploration feature of the reinforcement system, take the training, and put it into practice. So that's one way that you can take a trained reinforcement learning system and put it into practice without it exploring on real patients. You also need to consider all the actions available to the actor while you're designing your reward framework. So remember when we were talking about the vacuum cleaner and how it was rewarded by seeing less dirt, and it turned off its camera. Well, the failure there was not recognizing all the actions available to the vacuum, right? So when you're creating your reward system, you have to say, what are all the things that it can do? What of these things could affect the reward? And you can either remove some of the actions available, so maybe you just don't allow it to turn its camera off anymore. Or you could change your rewards to say, you have to see less dirt while your camera is operable, right? So these are kinds of some ways that you can resolve the issues, some of the issues with reinforcement learning. So data integrity and job security, and really just about any other problem. Well, ways that we can work with this to alleviate some of the issues: peer review, consider the appropriateness of your solution. So just thinking very deeply about your problems, talking to your peers, making sure everything is reviewed. And also, as other industries are regulated and have training requirements and licensing and boards to review their work, I think as AI grows, we're going to need some of that in this field as well. So another fix for a lot of the problems that are currently exist in AI are human-in-the-loop systems, which actually are some of my favorite AI systems. And can anyone think of any popular human-in-the-loop systems that are available to us today? Yeah. Oh my gosh, yes, CAPTCHA. That's so, I hate those. Yes, that's correct. That's definitely a human in the loop. So also Google search, right? So Google search algorithm pays attention to the actions of its users for a PageRank algorithm. So if you click on one of the top search results and quickly bounce off, it's going to change the PageRank algorithm based on the fact that it seemed to be an incorrect result for you, based on the search that you had. So it's learning from the people who are using the system, and it continues to learn. So every time you interact with Google search, it learns from you. It's also starting to predict the text that you're going to type in, which is interesting sometimes and has its own biases. Another one, Stitch Fix, is a recommender system with a human fashion expert in the loop. So the recommender system makes a recommendation, but there's still a human there, like interacting with the customer who's buying the clothes, and getting feedback and adjusting the system. And so the system continues to learn from the fashion designer who's working on the other end. So there are a lot of human-in-the-loop systems, and these are really, really great ways to develop AI. So remember I said AI, to think of AI as a system. So even outside of these human-in-the-loop systems, AI systems still interact with and learn from humans. So even if you don't have someone directly in there, like if you're looking at Netflix recommendation system, it doesn't have an expert there that's adjusting the opinions, but it's still learning from its users. And it still needs users to use the platform in order to learn. And so these systems really need to be user-friendly. And so an AI system can be kind of symbiotic in that way, right? So you have human performance is augmented by the AI, but also the AI continues to learn from the humans that are using it. So this is also really important when you're talking about job security, right? Because we're not sure how fast AI is going to start replacing some jobs. But these human-in-the-loop systems are great, and they also help with the transition. So if you think about medical-related AI, right? So I work with some radiologists, and we were talking about AI with radiology, and can computers really read medical images and say, oh yeah, there's a tumor there, there's not a tumor there, or whatever. And the radiologists are getting really nervous as we're having this conversation because they're going, are they going to replace me? Am I not going to have a job? Is radiology going to cease to exist? And I'm thinking, I don't think that will happen for a really long time for all kinds of reasons, but also I think it's going to be more of a transition to where those same doctors are still going to be required to interpret the results of the AI. So as AI would learn from them, right? So they create reports, they look at images, the AI is sitting in the background, looking at the same images, looking at them as they're creating the reports. And it can kind of learn from them and start doing more. It'll start predicting, hey, I think this should be in the report. I think this should be in the report. They can adjust it and correct it. And as the AI gets better and they spend less time doing the reports, they can spend more time with the patients explaining to them the results of what they read, or the doctors. Sometimes they talk directly to patients, and sometimes they talk to other doctors, but there's still an interpretation element that's really important in all of this. And generally speaking in AI, I think that's kind of the direction things are going to go in. Like, people need to understand when they should be correcting AI, how it works, when they shouldn't, when should you trust an AI result, and when should you correct it, right? And there's a learning curve there. And we're always going to need humans in some capacity with these systems. And I think the focus is going to come for the human users more in interpreting and understanding how to use the AI than doing what the AI used to, what the AI has started doing for them, they will no longer be doing, but instead they'll be interpreting the results and making sure that they're applied correctly. Okay. So here's an example of clean data that you get from a human-in-the-loop system. So I have always hated chatbots, like a lot. And also, partly, I think it's worse for me because my early focus in data science and AI was in natural language processing. And so when I get into a chatbot that has free-form text fields, I'm always trying to think, how is a computer going to interpret what I'm typing in, right? And I'm always trying to think like the computer, and then I just get really frustrated sometimes. Like, I've got to ask a question I know it's not going to understand, and like, can I just get through to a person, you know? And so what I really like that they've been doing with chatbots lately is these predictive fields, right? So instead of having the free-form text fields, it'll ask a question, like this one says, what does it say? I can't read it from here. Don't catch that. I've been working so hard in the studio. So anyway, it's saying, do you want to respond with carry on, shop, or try on sunglasses? Well, this is kind of a funny example because this person made the bot that has the options and somebody still typed an answer in, and then it couldn't understand it, right? So 2 things on this. Like, one, having the text field, having the tags instead of a free-form text field gives you way better data, it's a better user experience, et cetera. With the human responses, again, like you really have to think of these systems because you have people using the system. And if people don't know how to use the system properly, or you've not built it in a way that it makes it easy for them to use, you're going to get junk, right? And it's not going to work well. So you really have to think through how you're designing the whole system and not just the machine learning or the back-end AI, the smart algorithms. Okay, so this is kind of how I envision an entire AI system, right? So you've got UX, UI, who does the user research. How are people going to interact with this thing? Is it easy and intuitive for them to use? And while at the same time functioning the way that we need it to function. And then you've got kind of the data science, machine learning piece in the back end, and software engineering, obviously, to build out the front end and whatever other pieces that you have. And so this is kind of what I think is required to get these systems up and going. And this is just kind of another illustration of how the human in the loop fits in there. So the human using the computer, the data goes to like a data warehouse, and it goes through your machine learning, and then it's going to make some predictions that are returned to the human. The human's going to make a selection. That selection's going to go back into data. And the loop just kind of continues to repeat as the users use the system and the AI makes the predictions. Okay, so are there problems with human-in-the-loop AI systems? Yeah, of course. Most notably when humans rely too heavily on the AI. So I think something I always think of with autonomous cars right now, there's this in-between period that's almost worse than being fully autonomous or not autonomous at all, because people aren't paying attention. So if you think about like the Uber self-driving cars, yeah, they've got a human sitting there, but they're not ready to react. That's why the Uber hit a pedestrian down in Arizona, right? Because there was a human driver, but she's not ready to drive. The car's driving, So she's not prepared to stop immediately. And the other thing about that system is, so Uber put their autonomous technology into a Volvo, and the Uber autonomous technology actually turned off the Volvo's emergency braking systems. And so when they went back and investigated what happened, they found that the AI did detect the person, and it knew it needed to stop, and it had time to stop the car, but it couldn't stop because it couldn't engage the emergency braking systems because their system had turned off that functionality. And so, it's just another example of how you really have to think very carefully about how you're designing the system as a whole, and how people will actually interact with it. And then the other problem that occurs with humans in the loop is, like I said before, when they don't understand how the AI systems are designed or intended to be used, and they use them incorrectly. So I think, like I said, as we transition jobs to more AI-focused systems, there's going to be some training. There's still going to be people that are needed, but we're also going to need a lot of training of people on how to really use and understand these systems. Okay, so that's all I had. Any questions? What do you use to reward an AI program? Oh, it's like a point system. So like in Pong, for example, if it actually hits the ball as opposed to misses the ball, it'll get a point. If it misses the ball, it doesn't get a point. And so it wants to hit the ball as many times as possible, and that maximizes its reward. And it could also be, so you think about, we think the word reward always means like you're getting something good, right? But in this context, they also use the term reward as like could also mean punishment, right? So like, for example, with the vacuum, if it sees dirt, that's a punishment because it wants to minimize the amount of dirt that it sees, right? So you can kind of think of it, it can kind of go both ways. It's a little foggy on the vocabulary there.
Awesome. Any more questions for Kristin? Let me come over there.
So with the neural network, I really like your example of it. I think a great example that I've seen implemented is a neural network calculator. Basically, it's when you add it, you feed it a bunch of training data saying 1 + 1, 2 + 2, and everything else, and then at the end it gives you a calculator, and then you add up simple numbers like 2 + 2, and it gives you 3.95674, because it doesn't really know what 2 + 2 is. It just knows the probability that 2 + 2 equals this certain number is this.
Right.
So there's always a trailing number.
Yeah.
But so how does that help with delivering healthcare? Is that what you do, I guess? You use artificial intelligence to help deliver the healthcare, or you're using it for, I'm not sure what you're using the neural networks, artificial intelligence for, as far as the healthcare goes?
Yeah, so you can use it for a couple of different things. And in terms of like actually, so the example you gave, like if you did a 2 + 2, really bad use of a neural network. But if you were doing 2 + 2, like you can actually, a lot of the packages now I would probably treat it as some kind of classification example, in which case you can get the predicted class as well as the probability of the predicted class. So I think that might resolve that issue. Although I don't know how you get the training data for that. It'd be weird. Anyway, yeah, so there are a lot of ways that machine learning and AI can work in healthcare. Right now, what I look at is how to augment doctor performance, right? How to make their jobs easier, things that are kind of mundane, they don't like to do over and over again, try and automate some of those processes. So for example, like dictating reports, not fun, and they're saying the same thing over and over again, right? So if you can kind of use predictive text generation algorithms, kind of like Google does in their search now, so when you start to type something in, it'll like finish it for you. And sometimes it's right, sometimes it's not. So, you still have the radiologist sitting there looking at it and saying, yeah, that's right, or no, that's totally wrong, and they fix it. So that kind of thing, I think, are really good applications of AI in healthcare field specifically. There are other things you can kind of put data analytics into work. So if you're trying to get a better idea of like how long it should take to do a procedure, right? And so let's say there's something, let's say it's, so back to radiology, like you're dictating a report, right? Well, obviously the longer the report gets, the longer it probably takes you to complete that particular reading. But also there might be certain words in that report that indicate something that would make it take longer. Like if it's oncology related, it might take longer than if it's just a simple like broken bone kind of review. Well, you can use AI to kind of detect that and adjust the like assignment of work value for that particular item, right? So there are a lot of ways that AI can kind of sit in the background and help people both in data analytics and in actually the work performance.
We got time for another question. If anybody's got a question for Kristin. I'm going to go over here for purely efficiency's sake.
Is there any healthcare application that you have in mind, maybe something that you can't work on just due to feasibility, but something that AI would be a really good application for?
I'm not sure I understand.
A healthcare problem that AI would be a good solution for.
I mean, yeah, the ones that I just mentioned. And then, I don't know off the top of my head. I don't have anything in mind, but.
Kind of two questions. Oh, wow, that was really close. So do you guys interface with software like Epic and stuff to?
So not directly, but yeah, we definitely have to use APIs for transcription software, and because I'm not building my own transcription software, they've got stuff that works really well for that. Yeah, so absolutely, they're definitely the like image reading platforms as well. And I don't directly work with Epic or another. What do you call that, EMR system? But products that I work with interface with those, and then I interface with the other products, so yeah.
Cool.
There's a lot of API integrations generally in AI, I find.
So also, what's your tool set? What do you use to generate these neural networks?
Well, a lot of different things. I've used, actually, I find scikit-learn has a really simple neural net. I can't remember what it's called off the top of my head, but there's a regression one and a classification one, and honestly, for a lot of problems, like I always start simple, and that one works quite well. If I need to get fancier, usually TensorFlow. I like to work with Keras better than TensorFlow. Sometimes I have to get deeper into it, so I've got to use TensorFlow natively. I used to use Theano backend on Keras, some in natural language processing. I haven't done that in a while. And then sometimes I write my own, so. Yeah.
Do you verify whether simple classifiers work, or do you always go straight for neural networks?
No, I do not. That's a great question. Actually, I think someone mentioned this earlier. I'm not sure if it was Alyssa or someone else, but actually it depends on the amount of data that you have, right? So Andrew Ng very famously, in the neural network world, anyway, has a data visualization. I should really put in my presentation. And it kind of shows there's a curve, right? And it depends on how much data you have, what really starts to perform well. And you don't really hit good performance with neural networks usually unless you hit like maybe around 100,000 examples. And that also depends on how many classes you have as well, right? So like if you have 100,000 examples but you have 100 classes, that still might not be a lot of data for the type of thing that you're doing. If you have 100,000 examples in 2 different classes, so it's just a ton of images of cats and dogs, it'll probably work a whole lot better. But no, actually, if you don't have a lot of data, a lot of times simpler solutions do work well. But it's not always the number of rows you have either. So with natural language processing specifically, you usually have really wide data. So even if you don't have a whole lot of examples, because your data is so wide, neural networks usually perform better for those, I find. But other problems, no, I usually start as simple as I can.
All right, we'll do one more question.
Do you have any library recommendations for reinforcement learning? Like if I know I have an MDP or a POMDP, what should I use to solve it?
So Unity platform is a great platform for that. I haven't done a ton of reinforcement learning myself. There's actually, okay, let me take that back. There's a library called Ray, I think. R-A-Y, I think, if I remember right. It was designed by some students from Stanford. And it actually does, I think, distributing computing, but it also works with reinforcement learning. So you might check that out. And also their website will have some resources as well, I believe.
You mentioned NLP. Did you compare, for example, just simple TF-IDF and an SVM?
Yeah. Sometimes
Because we
that works,
found
yeah.
that often they're really hard to beat with neural nets.
Yeah, that's actually how I started in NLP. I actually used SVM was one of the first tools. Lately, it hasn't been working as well as neural nets for me in the particular problems that I've been working on. But the simple neural net that scikit-learn has is working pretty well on it. And usually I don't go to Keras unless like nothing else is working.